Hello, everyone, and welcome to the first panel event of CE's 40th anniversary. My name is Justin Ricketts. I'm a first year at Harvard University, and I have the pleasure of moderating today's panel. This panel will be about the challenges in science and technology for the submarine development and the future of the submarine force. Today's panel will start with a presentation by 4 experts in the field and will be followed by a Q&A. So be sure to prepare questions as you watch these presentations. Our first presentation will be a joint presentation on the future submarine force by 3 highly esteemed guests. The first is retired Captain Carr Hartsfield. Retired Captain Hartsfield entered the Navy in 1990 as a nuclear propulsion officer candidate and served aboard vessels such as the USS Los Angeles as a division officer, USS Parch as navigation operations officer, USS Nevada on his executive officer tour, and commander of USS Newport News, ending his career as a Commodore of Submarine Squadron 6 in Norfolk, Virginia. He is a master's graduate of the Massachusetts Institute of Technology, Woods Hole Oceanographic Institution Joint Program in Oceanic Sciences, and currently employed at the Woods Hole Oceanographic Institution as the director and senior program manager of the Oceanographic Systems Laboratory. The next speaker is Captain Thomas O'Donnell. Captain O'Donnell graduated from the United States Naval Academy in 2000 with a Bachelor of Science in Ocean Engineering and graduated from the United States Naval War College in 2015 with a Master's in National Security and Strategic Studies. He has served aboard vessels such as the USS Maryland as the Chemistry and Radiological Assistant and Communications Officer, the USS Virginia as the Exec Engineer Officer, the USS Providence as an Executive Officer, and the USS Oklahoma as a Commanding Officer. He is currently the commander of Submarine Squadron 12, a squadron of fast-attack nuclear-powered submarines at the Naval Submarine Base in Groton, Connecticut. Last but not least, we have Mr. Brendan Carr. Mr. Carr earned a Bachelor of Science in Naval Architecture and Marine Engineering from Webb Institute, a Master of Science in Naval Architecture from University College London, and holds his professional engineer license in Naval Architecture and Marine Engineering. He's the technical lead for SSNX in Electric Boat's Concept Formulation Group, supporting whole ship concept development, technology discovery and integration, and design space exploration for SSNX and other future submarine platforms. Previously, Mr. Carr was Naval Architecture and Concept Design Support for Columbia, Virginia Payload Module, Australia's C-1000 project, Moored Trained Ship, and Dry Combat Submersible. So, without further ado, please give a very warm welcome to retired Captain Hartsfield, Captain O'Donnell, and Mr. Carr.
Thank you, Justin. So we are all very honored to be here today to honor Admiral Rickover and his legacy to the submarine force in the Navy. Today is the Navy's 248th birthday. So happy birthday to the Navy, and I'm glad that we can celebrate here tonight. Vice Admiral Houston, who is the commander of our subforce in the United States Navy, sends his regards. He couldn't be here this evening. He's actually down at my sub base in Groton, Connecticut, because the USS Hyman G. Rickover, our next fast attack submarine, SSN 795, is being commissioned tomorrow morning. So he's down with the Secretary of the Navy and many others in Groton, getting ready for that important ceremony. So it's kind of fitting that we're here tonight getting ready for that commissioning ceremony tomorrow. So let's see, where's the clicker? So I figured it would be great to start with a picture of the USS Nautilus. That's her christening day at Electric Boat in Groton, Connecticut back in 1954, the U.S. Navy's first nuclear-powered submarine. And then that's the next submarine to be commissioned tomorrow morning, USS Hyman G. Rickover. That's just down the road or down the river from Subbase Groton at Electric Boat, and Rickover is heading out on sea trials. And if you look at this building right here, that's where the USS Nautilus was christened. So we saw it leaving the river right there back in 1954. So big difference in what our submarines look like about 70 years later, but that's the Rickover and her crew going out for sea trials. So I wanted to start with a quick summary of our submarine force, what we do, where we are. We have submarine bases on the East Coast in Groton, Connecticut, obviously, Norfolk, Virginia, where our submarine headquarters is at. We have some ballistic missile submarines out of Kings Bay, Georgia. On the West Coast, we have ballistic missile submarines and fast attacks out of Bangor, Washington. And then San Diego, which is a great spot, where I took command of my submarine. We've got Fast Attack Submarine Station there. Pearl Harbor, we've got 2 submarine squadrons, and then we have a submarine squadron all the way out here in the Western Pacific in Guam, actually where my submarine, Oklahoma City, was home ported for my command tour. We have our deployed operational commanders in Naples, Italy, and Yokosuka, Japan. So when our submarines go on deployment, they'll work for one of those 2 commanders. So I've listed here the submarine missions, and starting from right to left, ASW is kind of the quintessential submarine mission, anti-submarine warfare. So we've also got special operations where we can deliver SEALs and other folks in anywhere around the globe. We have mine warfare capabilities and anti-mine capabilities. We've got ISR, intelligence, surveillance, reconnaissance. So that's our primary peacetime mission. So when your sailors and officers go to sea on submarines, they're conducting ISR around the globe. ASUW is anti-surface warfare. So again, that would be a wartime mission where you could potentially target adversarial ships. We've got Strike, which is sending land attack cruise missiles from the sea to places where the president needs it. And then obviously the most important mission of the United States military is strategic deterrence. And our ballistic missile submarines, the Ohio class and the soon-to-be Columbia class, which we'll talk about here shortly, they operate below the sea and carry a large portion of our nuclear triad every day. So most important part of our force is definitely our people. We couldn't design, build our submarines or design and build the equipment that goes on board the submarines without great people. Can't man the submarines without great people. And this just gives you an idea of the high-quality talent that the U.S. Navy needs every year, 440 officers to join our nuclear sessions program. That's about the numbers we take annually from both the Naval Academy, ROTC programs. STAY 21 is Seaman to Admiral program, so that's taking enlisted sailors, sending them to get a commission, to get a degree and a commission. And then the NUPOC is the Nuclear Propulsion Officer Candidate School, so taking personnel in college as they work through their degree, then commissioning them into the subforce afterwards. For the enlisted sailors, we need to assess about 3,200 sailors into the nuclear propulsion program, and that 60% of those go to submarines and 40% go to man the nuclear propulsion plants on our aircraft carriers. For those 3,200 sailors, about half of them will become mechanics, another quarter electricians, mates, and then another quarter electronics technicians. So those are critical rates that support the nuclear propulsion plant throughout our platforms. So it's not just getting great sailors and officers to join our ranks. We've got to retain them, and that can be hard to do in today's economy. So we offer opportunities, Naval Postgraduate School, Naval War College. I know that Carl will talk about MIT HUI program. He's a graduate of that. University of Pennsylvania, and all sorts of other graduate education vouchers that we can entice officers to go to shore duty, get a higher education, and then that they can come back to the submarine force as a department head and continue to help the submarine force in the Navy. There's also opportunities at university-affiliated research centers for our division officers, our young lieutenants, to roll to shore duty and take a position helping one of the physics labs or research labs across the country. University of Texas, Penn State, Georgia Tech, all sorts of great programs, and there's other programs with federally funded research centers as well that help the Navy and the submarine force. Those are all great opportunities to try to keep technically minded leaders in the submarine force, in the Navy, helping develop and train the next generation. Okay, turn it over to Carl.
Thanks, Commodore. So let's highlight one of these programs, right, that's very near where we're at right now, which is a joint program that was started in 1967 between the Massachusetts Institute of Technology and the Woods Hole Oceanographic Institute. So, it's a great combination, right? So you get one of the best, if not the best, technical school in the world, and you pair that with the hands-on prowess of Woods Hole engineers and scientists, and it's a great match, right? And if you can't make it better, the best thing to do is immerse students into that kind of arena, right? And so since 1967, they've graduated almost 1,100 degrees. They've went through their 50th anniversary, and it's pretty important to say that about 10% of those graduates have been naval officers, like the Commodore talks about here. They go on to be, power players in the Navy. One was actually the Chief of Naval Operations recently, John Richardson, and that's his quote in the bottom. And he basically says the MIT Joint Program is a crown jewel, right, in both our Navy and also in academia. And it's kind of important to say that about 60 scientific papers a year come out of the students. And they graduate both PhDs and master's candidates, and the Navy group gets master's candidates. But what this is a testament of how the military can partner with academia to make something better. And I'm sure Admiral Rickover, was very pleased with this program, and it is very much like what he had in mind when he started this program that you have here that's so brilliant.
So electric boat, obviously it's a very exciting time to be designing and building submarines. We have the Columbia class in full production. Virginia, obviously we're procuring 2 per year, and our hiring needs are incredible, and we need very skilled people, and also people willing to learn. Right, we have vocational schools, we have technical colleges, we go into STEM incentives for high schoolers and above. We're going to hire over 5,000 people this year alone, just electric boat. Engineering's across the spectrum: acoustic engineers, structural engineers, hydrodynamicists, you name it. We're also obviously have to build the submarines with a lot of operations or construction support. That'd be welders, pipe fitters, ship fitters, electricians. It's work that provides a purpose. You just saw the Commodore give about everywhere in the world, all the missions that are very important to us as a nation, and that's what this work provides. It provides a reason to want to come to work every day and do something that you know will make a difference. And in order to meet the retention issue is everywhere in the STEM fields right now, and we're trying to do our best as well with professional development rotations, technical rotations, to find out if you like something a little bit different, some continuous education things as well. It's a really neat opportunity because you get to go down a submarine when you want to take a look at what you helped design and build. And then also, go up to the base, and the Commodore lets us talk to the folks that are actually out there, the warfighters, trying to understand what their needs are, what things we want to update going forward. And even just not at our shipyard electric boat, over 10,000 people need to be hired annually for the next coming decade to be able to support this crazy high buildup that we're having because of the demand of submarines and their importance they have going forward.
Thank you. So we talked about all the importance of recruiting and retaining great people into the Navy, and obviously my panelists with me here also showed how important it is to get those great people in industry. So not everybody wants to go submerge a nuclear-powered steel tube in the middle of the ocean for months at a time, and that's okay. But there's lots of ways that as people here in Massachusetts would say, wicked-smart people can help out the Navy and the submarine force, even without having to raise their right hand and put this uniform on. So I want to show you the classes of submarines that personnel in the Navy are manning today. We've got upper left corner, the Los Angeles class. So the Oklahoma City, which I commanded, is one of those class submarines. That number is coming down as we decommission those. Oklahoma City was commissioned in 1987, and she decommissioned late last year. The second across the top is the Virginia class. That's a workhorse of our fast attack submarine force. And you can see a shadowed version of a longer Virginia class there. That's a future block being built at Electric Boat of submarines that's going to have a 84-foot section for additional weapons capacity in the middle of that submarine. So that goes to the ingenuity and design engineering of of our submarines is that we can just extend it and it still works. On the upper right, SSBN, so that stands for our ballistic missile submarines, the Ohio class. So that is the workhorse that is holding strategic deterrence against our adversaries today and has been for decades. That class is will be eventually replaced below it by the shadowed version of SSBN Columbia class. The first Columbia is being built and should be delivered to the Navy in about 2028. I've seen many portions of it at the ship facility in Quonset Point, Rhode Island, and it is impressive. It is a lot further along than one would think, and it will be here before you know it. In the middle bottom, Ohio class SSGN. So we took 4 of our Ohio class and converted them from ballistic missile capability to more of a tactical weapon, and we can put Tomahawk cruise missiles and other weapons, and they can deploy around the world, and they provide a lot of assistance to our combatant commanders to execute missions around the globe. And then finally, in the bottom left, Seawolf, which was a Cold War designed fast attack submarine and part of a Cold War peace dividend in the 90s that we stopped building them after about 3 instead of the 30 that was originally designed. And eventually, she's a very capable submarine. We just only have a few of them that are still out in the fleet right now. So a little bit more about our strategic deterrent. Number 1 mission of the Department of Defense is holding strategic deterrence. That allows everything else we do within the military, within our country, to happen the way it does today because we have a silent ability to be out there and to have that threat of use, hopefully only a threat of use, there for our adversaries to think about. The Columbia class is our next replacement, as we mentioned before. Production is going well down Electric Boat, but there's no margin for error. When Columbia delivers, she needs to be on strategic deterrent patrol by 2030 because the Ohio class are going to crest over 42 years of service, and we're even actually looking to try to push a couple out to 45 years of service. And for all the personnel here with engineering and technical backgrounds, think about a steel tube that was built 45 years ago, and you're going to go submerge it and expose it to the sea pressure, which is relentless, and the crew is going to take it out there and execute the mission. So it's very important that we get Columbia delivered on time to the fleet. For our fast attack submarines, right now we're, if you look at the upper right, we're extending our SSN capabilities. We're developing new weapons, longer range, better sonars that can hear with higher fidelity. We're restoring our readiness in our shipyards. Again, kind of a Cold War dividend, peace dividend, was that the numbers of submarines were going down, the submarine repairs weren't required as often, but now we're ramping that back up, and our shipyards are getting restored back to where they need to be to get our submarines repaired and back to sea. Evolving Virginia-class lethality, that was the extended Virginia that I talked about before and adding more missile capability. You can see enhancing the industrial base, that's the forward section. You can tell there's nothing after the sail. That's just one portion of a Virginia-class submarine getting delivered down to Electric Boat and Groton. If anybody's ever driven from Newport down here, down to the south to Groton, you'll see sometimes pieces of submarines on barges getting towed from Quonset Point down to Connecticut. I've happened to see it a couple times myself. And then obviously SSNX, so that means the next fast attack submarine, and Brendan will talk a little bit about that since he's in that program at Electric Boat. We're developing new weapons, new missiles, new torpedoes, longer ranges, different types of weapons, land attack cruise missiles, anti-ship missiles, subsurface air missiles, all sorts of new gadgets to add capability to our future submarine force. For the Columbia class, so this is part of this program is joint with UK. So the next SSBN that the Royal Navy will have a common missile compartment with the U.S. Navy, and they share the D5 Trident missile. For Columbia class, it will also be electric drive. So think about your electric motor for your Tesla or whatever your EV is, and then scale it to propulse a 20,000-ton submarine at speed and depth. Let's see, and if you can see the modular design, which is right here, they build the internals of the submarine and then slide it into the hull as they're constructing it. For Virginia-class submarine, so I was stationed on a Block 1 Virginia, actually the Virginia. Right now, Block 1, Block 2, and Block 3 are out in the fleet. Block 4 is start slowly coming into the fleet here. That's the next round to get commissioned. And then Block 5 is the future of our submarine force, will be commissioned later on this decade. And that'll have the extra payload capacity that we mentioned in previous slides. And then the SSNX program, so that's looking forward to the 2030s, 2040s, 2050s. What capabilities will I have? What will I need to be able to compete against the adversary? How lethal do I need to be? How stealth do I need to be? All those are going to get wrapped into designing the next fast attack submarine that Brendan and his team and many others in the Department of Defense industrial base are working on just today. To give you an idea about where submarine construction is going, so this was the initial Cold War push to build SSBNs and fast attack submarines. This was the 1970s and 80s when we needed to recapitalize our strategic deterrent force and build the Ohio class. And this is where we are on the ramp up to include building 2 Virginia-class fast attack submarines and 1 Columbia SSBN every year is where Electric Boat is heading. And that'll get to the tonnage per year way up here beyond anything that we've seen in our country. So this is a great place to be. It's an exciting time. It also leads to why Brendan and the team down in General Dynamics Electric Boat are hiring a lot, along with us needing to recruit more officers and sailors to man those submarines. And if we don't get that production right, if the shipyards are late and the shipbuilders are late, right now with delays from COVID and other things, we're essentially leaving 7 submarines at the pier, right? So delays in shipyard, meaning they're not turned back over to me as an operational commander so I can deploy that submarine, or delays in construction so they can't get out to the fleet for the first time and be ready to deploy. It's equivalent of 7 submarines that we should have at the fleet right now that are being worked on. And what that means for the country is that's 150 plus torpedoes that aren't at the fingertips of the president and the combatant commanders, and that's over 80 cruise missiles that aren't there for the president to use if need be to defend the country. So that's the risk that we have if we don't have great people to design, build, man, very technical piece of equipment, the submarine. And on that note, I'm going to turn it over to Brendan.
So submarine design, at the end of the day, is a very complex system engineering process with obviously a very important purpose, as the Commodore has gone before.
Would you please hold the microphone?
Oh, sorry. Is that better? Okay. So a complex system engineering process, a problem that we have to go through with very, very important, very large ramifications if we get it wrong. So when you go for just a high-level approach to submarine designs, the Commodore or some other folks in the Navy come down and say, I need to complete these missions. I need to complete these missions against these things in these environments. How do you then do that? How will the ship operate in that environment? What will it need to be able to complete its mission? Those are the capabilities it needs to do. And at the end of the day, what are the technologies? What are the actual physical solutions to allow you to get those capabilities to complete those missions? A standard approach to engineering and design as you get through, but it's very daunting because of the complexity. We have a steel tube that's underwater for 40 years. Well, it's not just a steel tube. It has a nuclear reactor in it, has people in it, it has explosives, sometimes nuclear warheads on it. How do you make sure you can design something that is safe and effective, that is thousands of tons, that can be underwater as long as it needs to be, and its job is not to be found. That is a very daunting task. It's some of the most complex things that human beings design and build on Earth right now. So how do you handle that complexity? It's kind of an old adage, but small bites at a time. It's an iterative process. You slowly but surely bring those things forward. You iterate the process. You start building things. You learn from previous mistakes. You go forward. You use new tools, whatnot. Since the classification of this meeting, I can't go into actually what we're looking for SSNX. It's very exciting. So if anyone wants to join the Navy Enterprise and trying to figure out the next design, there's really, really amazing things going on, but I'm going to try and bring it down for a little bit of easier talking at this level. So for example, Commodore comes to us and says, I need to slay giant sea monsters and interdict undead pirates. Those are my mission sets. How do I go about that? So we're going to go through a little design exercise on how you actually approach this for submarine design. Very scary, but we have to take it on. It's important. So you evaluate the mission. What do you need to do? How is a submarine going to go against those different threats? How is it going to complete those missions? How do we expect the undead pirates to be operating their ghostly wooden sailing vessel? What kind of giant sea monsters are we concerned about, and how they operate? So you go through and you understand what the process is, how you're going to approach that problem. And you understand what that means. What does the submarine look like to do that? So for interdicting undead pirate operations, probably one of our current submarines can do it. Their boats are kind of slow. Their cannonballs can't really reach underwater. They really only can use a spyglass, but we have much better things to look at it. So Virginia and the current submarines might be able to do it. Might have to upgrade a little bit so that they can detect ethereal ectoplasm and wood instead of a steel hull. But you can make it make it worth what you have. Giant sea monsters, on the other hand, I don't know if you've seen them. They're really bad. So we have to worry about, the boat has to be really, really stealthy because they have really good hearing. They have the ability to swipe at you, so you need to have really good survivability. You need to hear them far away so you can get the first shot off. You need really specialized payload to take them out, and all the things. So that drives you, like we are with SSNX now, to a new class. The future threats, or the threats we know we're going to face and the missions we're going to have to complete require a new submarine design. So you now know the capabilities. So now you need to have identify the enabling technologies to go forward and complete that mission and build something together. In this case, giant sea monsters, you need a supercavitating harpoon. That is allow it to injure it and slow it down. It can penetrate its hide, and then at least start the process. And then you need the high-yield maritime Angry Bird to be able to finish the job once it's slowed down. So you go through, you identify the technologies. First part done. It's more complicated than that. Obviously, it's systems engineering. So how do you load them? And I'm not talking about just reloading the ship. How do you bring them from outside the ship to load them initially? How do you reload at the pier to be able to bring them on mission? It's a steel cylinder. You don't like punching holes into it. How do you handle that? How do you program them, right? What combat weapon system needs to talk to this payload to be able to do that? How do you handle them? Do they need certain handling points? Do you not want to touch certain areas because it's sensitive? Can they not be jostled around because they have explosives in them? How do you target them? What is the targeting methodology? What is the ship giving to that payload to tell it what to do? How do you launch them? Do they have their own launching device? Do you have to provide some impulse from the ship itself? And how do you communicate with them? Do you want to be able to communicate them after you launch them because the giant sea monster moved? You have all these systems, all these things that you develop to make these technologies work. Unfortunately, even though we're talking about undead pirates and sea creatures, physics still works. Physics still rules at the end of the day. Archimedes is still right. It has to float. Otherwise, you're a seabed system, and that's usually a bad day for a submarine. And now the easy part is done. You have to do what we're going through right now, is how do you source it? What materials do you make it out of? How do you build it? Who is building it? Where can you do the building? Do you have to build it off the hull or inside the hull? Can you build on a module, as the Commodore showed, or does it have to be built inside in really tight spaces? How do you test it? You have to make sure that it works before it goes out so that the operators can actually use it and trust that it will work. And how do you train them for it to make sure it's the most effective use of it constantly? How do you maintain it? Do things wear out? Are things sacrificial? And how do you upgrade it? We just talked about decades of life on some of these platforms. What if the giant sea creature grows an extra set of armor and you have to add a different type of a blade on the front? Does that change the weight? Does that change how you program the targeting solution? All these things. You think of the cell phone in your hand. How often do you get rid of that and get a new one? And now you're asking something that's going to be decades that has to have the best technology possible. How do you even start that process? And then from that, eventually you create a viable and capable system. As I said, these are some of the most complex systems that humankind creates right now. How do you make sure that that is effective and does its job, which is very important to all of us? And going back to something that's not that mythological, it has a purpose, right? You know what you're doing every day matters. And even though that's our slogan at EB to make sure that we understand our drive, what matters, that is kind of the overall enterprise, is delivering the advantage to make sure that we maintain our undersea dominance and be able to use that to maintain our freedom and security. And with that, I'll go to Carl.
All right, folks, we're going to go into this presentation. It's going to be a little bit different. It's going to be about uncrewed, unmanned vehicles that operate underwater. So you've heard a lot today about things that cost $3.5 billion. I'm going to show you things that cost $3.5 million. But we still don't want to lose them, right? So what kind of things does the lab at Woods Hole that I run, what do we do? Well, we're about 42 loosely confederated pirates who do everything from design to operate to repair to train sailors to put these systems in the ocean and sell them to different locations and develop. So we have 42 people that do this, and we're one of the world's leaders in uncrewed vehicles. So these are some of the vehicles that we've developed over the years. Our lab started in '89. So we've had quite a bit of time, and we've started from this little vehicle that you see at the top. Oh, you see that little vehicle at the top is a Remus 100, and those numbers are its depth rating in meters. Not classified how deep it goes. Some of the work that we do is classified, and you can see a whole host of vehicles here. The deepest vehicle here, for instance, is this guy, and he goes to 20,000 feet. So 97% of the world's ocean he can survey. Some of them, well, let me see here. Let me get back there. And I'll tell you what, I'm going to put this down, and can somebody advance the slides for me? Do we have a slide advancer? Yes, sir. Yeah. So, if you go to the next slide. All right. This is easier. Right. So, so some of these vehicles are designed to go really, really deep. Some of them are actually designed to go really fast. If you see that vehicle, Mako, it actually does 15 knots. So a nominal underwater vehicle does about 5 knots. So we can point design these vehicles to whatever the customer wants to optimize that parameter and build that vehicle. And we build a lot of prototypes, and some of those prototypes go into production. But I can't talk about a lot of the work we do today in this arena. Some of it, I can tell you, our customers, as you see the submarine on the screen there, the submarine force is one of our biggest customers, and we operate off nuclear submarines. As a matter of fact, our systems are loaded on a submarine in the Pacific right now. Commodore O'Donnell and I went to sea just a few months ago on a submarine to test one of our systems. So we operate with the submarine force. We also operate with the Navy SEALs, the mine warfare community, but we do a whole host of science. We run vehicles in the world looking at fan coral. We run vehicles in the world that have plankton pumps on them. We run vehicles in the world that look for oil plumes. We track sharks with our vehicles, and sharks have actually attacked our vehicles. So we do a whole host of things in the world. But when I came here today to talk to you guys, I thought, if I was at a cocktail party and I had to talk to Admiral Rickover and I couldn't say anything classified, and I wanted to keep his attention, what story would I tell about these vehicles before he booted me out of the room. So I picked one of those stories, and I'm going to talk to you about it, and I want you to interject if you have questions, and I'm going to ask you questions. Does that sound fair? All right, let's go to the next slide. So the city of New York had a problem. The city of New York gets its water from about 3 different locations. And one of those locations is the watershed for the Catskill Mountains, and there's a tunnel that goes under the Catskill Mountains and goes to New York. And you can see that tunnelway right there. The red section goes over onto, crosses the Hudson River and actually goes down on Long Island, and the water gets supplied to Manhattan. It's called the Roundout West Branch Tunnel. It's 57 kilometers long. It goes under the mountains, and at times it's 3,000 feet beneath the surface. And that tunnel is about somewhere around 18 meters, well, actually 18 feet in diameter. You could drive a Jeep through it when it was built in 1942, I think. 30% of the water supply to New York goes through this tunnel. So if you've had a glass of water in Manhattan, the likelihood that you drank some of this water is high. But what's the problem here? Since it's built in the 30s and 40s, they started noticing that they had leakage. And what if this tunnel collapsed? Could we handle a third of New York's water supply going away overnight? I mean, that's certainly a problem for New York, but it's actually a national problem, right? So how do you judge this tunnel that's so deep in the ground, that travels so far? How do you look at the inside of that? Can you do it with an ROV? Does anybody know what an ROV is? Remotely operated vehicle with a tether? Do you think you can do it with an ROV? Anybody? 57 kilometers, that's a pretty long tether, right? So no, you couldn't do it with an ROV. There was no system in the world at that time that could travel this 57 kilometers. And the point was to image every square inch so that you could look for cracks, screw heads, cave-ins, all those kind of things. You want to know what that is. They did not even know whether the tunnel, the liner was still intact. So how do you solve this problem? Well, my team stepped in to solve this problem, and when I say my team, I'm talking about the whole historical my team since 1989, and I'm not going to tell you when we did it, because I want you to tell me when you think we did it when we get to the end of this brief. Okay, let's go to the next slide. This is what it looked like when it was built, right? So, like I said, they drove a Jeep through it when all this concrete was poured, and I had a picture at one time of the Jeep driving through the tunnel under the Catskill Mountains. Totally filled with water, right? Next slide. Oh, and by the way, 30 million gallons per day was the leak rate. 30 million gallons per day. Right now, today, the leak rate is nearly 70 million gallons per day. Right? You know how they knew it was leaking? Does anybody know? How do you guess? Yeah. Yeah, they knew that the amount they were putting in, they knew the amount they were getting out, but what they also knew is on top of this tunnel, all along the way for 57 kilometers, there were oases of vegetation that were unexplainable in any other way, right? So it was creating a garden that was 57 kilometers long, right? So what my team did, and my forefathers did, is they created a vehicle that you could put in this tube. Now let's talk about this vehicle. You've got to have a camera, you've got to have light to take a picture with a camera, and you got to stay in the center of this aqueduct or the picture's not going to be focused, right? You can't see something that's the size of the screw, of a head of a screw, if you're not at the right focal length, right? So we had to design a vehicle that could position itself in the middle of the roundout tunnel, and it could take a picture with cameras that were all around the vehicle, right? So that there was overlap between those cameras and we didn't miss anything. And then look at that upper right photo. That's no joke. That's the hole it had to go into. That determined the diameter of the vehicle. We couldn't go up there with jackhammers and bust up all this land to put a vehicle in there that was really, really big, right? And the vehicle had to swim on its own and it also had to be pushed with water pressure. So we'd put that vehicle in, and we would run it at a speed, and when they wanted more footage, they would slow it down by backing the flow rate off. And they could control the vehicle speed with both its propeller autonomously. This vehicle's not remote controlled. It was 100% autonomous. And they could change the water flow, and we could do the speed, right? So another important thing about this vehicle is that it had to be ready for the unexpected. It actually had titanium whiskers on it. Why do you think it had titanium whiskers on it? Anybody? Right. If it got in trouble, this tunnel weaves, right? So let's say the vehicle gets in trouble. You don't want the camera to go crashing into the side. So there were titanium whiskers that stood out on the front of it that would hit the side of the tunnel until the vehicle could catch up and get back in the center. And when it came out, I'll let you know, one of those titanium whiskers was half as long as it was when it started. So she did hit the side a few times in the first run. But she actually did go in there, position herself in the center, and use lithium-ion batteries to go through that tunnel. Now, why would I say lithium-ion batteries in drinking water? Does anybody know why that might be a problem? Yeah, well, you know, there's the explosive, there's the energy, there's the fact that if that thing didn't make it, do you think we were then going to design a system to go in and pull it out? No, I mean, if we failed, the likelihood was this vehicle was going to be in the bottom of that tunnel for the rest of our lives. And as that battery corroded, what would it do to the drinking water, right? So we had to design this vehicle to live in that tunnel if we failed and not kill people in New York, right? Pretty interesting problem, right? So do you guys think Admiral Rickover is still listening, or has he booted me yet? All right, let's see. Let's go to the next slide. So this shows you the resolution that we had. See those hinges there? We actually could see screw heads. We could see cracks. They were able to map miles and miles and miles of cracks, find out where the leaks were. And they had this really cool view pattern there where they could look at, you know, the whole tube. And it was a huge problem for them to review all the data, because at that time, and I'm not telling you when that time was, we didn't have AI methods to go through the data and tell us if there was something we needed to look at. A human had to look at it all, right? It took 2 years to go through the data set, right? So it was a very, very wicked problem. It was a very, very cool problem. It was a moonshot problem. So I will ask you is, what year do you think this was done, based on what you know about technology? 1995. Close. Anybody else? 2001. Wow. So this was done over 20 years ago. So think what it would cost to do that today. And remember, I'm not talking about take a vehicle that you have and modify it. I'm talking about, I come to you and say I have a problem. You give me money and I build a vehicle and I solve your problem. How long do you think it took to build this? Remember, at that time, this group was 12 people. How long do you think? 10 years? Did it in 24 months. It cost $2 million. So even if you say today that I'm going to inflate that number, it's $5 million, right? So what this proves to you is that there are places in our country that have wildly innovative routes that can do amazing things. But it's putting need together with group that often is what we have to focus on, right? Because we are in a wildly innovative country, right? I will tell you that this problem is near and dear to my heart right now, because I lead the lab. When this happened, I was a graduate student in the lab, and I watched the city of New York come up and go through these pictures, and they just could not believe the amount of data that they had to sort through, right? But it was fun hanging out with them as a young lieutenant commander and watching them analyze this data. But now the city of New York has come back to me, and they say, we want to do it again. So I've pulled this vehicle out of storage. It is totally obsolete. I have a plan to refurbish this vehicle, and I had to bring a lot of older gentlemen and ladies out of retirement And, you know, it's kind of like that Space Cowboys movie. And so we're getting the band back together again, and we're going to put this vehicle back through that aqueduct, and we're going to photograph it again. We've done it 3 times for New York and 1 time in Scotland. And to date, we're the only group in the world who has photographed an aqueduct of that length, you know, from soup to nuts. So next slide. So this is about 2/3 of my team today. We're a real simple, small mom and pop band of pirates, right? And you see some of the vehicles that we build. It's my pleasure to lead them. I'm their confederated leader, but that could change tomorrow. But if you want to come see us at Woods Hole, please come and see us. Got a question?
Yeah.
Yeah.
How'd they fix the problems?
All right, so that's a good question. The first time they decided that it was not technically feasible to fix the problem because it would cost too much money. But what they did do was they planned all of their future development and their bypass tunnels on the data that they learned. So now they know zones in that section that are high leakage rates, and they're building around them. To go in and dig down and repair it was not technically feasible. If you go back to the picture, they're replacing a branch that goes under the Hudson River, and they use this data to decide how to do that, where to do that, how deep it needed to be. What they want us to do now is swim it and get one more snapshot before they put some of these changes in place. Yeah, so you could say that that's not a fix and that they didn't dig down a mile or, you know, 20 feet or whatever the depth is, and they didn't excavate it. You know, why they were afraid to fix it was the continuous water needs of New York. They can't even turn it off, right? So they have to build a bypass channel. They can't, it's got to be make before break, right? So does that answer your question, sir?
Yeah, thank you.
Anybody else have a question or want to challenge me on a point or anything? All right, thanks.
Okay, let's give it up one more time for retired Captain Hartsfield, Captain O'Donnell, and Mr. Carr. So you all just heard about the future of the submarine force, but let's take a step back and learn about the past. Our next speaker is Professor Neil Todreas. Professor Todreas, formerly Lieutenant Junior Grade in Naval Reactors, holds a bachelor's and a master's in mechanical engineering from Cornell University and a doctorate in nuclear engineering from MIT. He is a current Korean Electric Company professor of nuclear science and engineering and mechanical engineering at MIT. Throughout his illustrious career, he has earned a variety of awards and publications, but today he will be highlighting his personal experiences with Admiral Rickover's Naval Reactors Organization, which he personally experienced from 1958 up until the Admiral's passing. So please, without further ado, please welcome Professor Todreas.
Thank you. Thank you. Okay, so this will be a little bit truncated given the great layout of things we've heard. I was really impressed by the other speakers here and the information they put across. But how did it all happen? How did it all really come together? I submit it was because of the ethic and the technology and the commitment that the Admiral built into the program that these guys all inherited and are following with their unified things that they are developing. One thing I learned, I came from a town, there's 3 of them, that claim to be the birthplace of the U.S. Navy. And I'm happy to hear it's happening tomorrow. Terrific. Okay, so what about when I say Rickover was the financial foundation of these accomplishments, what do I mean? Well, first, his focus on education, and secondly, his achievement of technical accomplishment. There's a famous quote by a member of Congress who called Rickover 98 pounds of brains and guts. Whether it was 98 pounds or not, I don't know. My impression in dealing with him was he had a few more pounds than that. But 98 sounds good. But the Admiral's ultimate strength was commitment to excellence. And CEE is very well named, given that observation. So let's start with education. He focused on people, on selecting and developing his team. His senior group was small and was made up of people who he had worked with before during the war, during working on assessment of battle damage, and he had a very small team. I would say the senior group of the 250 or so people at NR were about 15 to 20 people. And they were all, of course, direct reports. Any business school would tell you that's too many. And that's links to the Admiral's view of business schools. If you've ever seen anything written, he had respect for the specifics they were teaching, but not for the organization of putting them in a business school and creating that kind of education. His other group was NROTC graduates. About 20 to 30 of us per year were taken in to naval reactors. And the focus of the Admiral's attention on this group was amazing. First of all, he required that we all take a course at a local university evening after work, that met at least twice a week. So that blew 3 to 4 hours of your evening time. Then we used to get in the mail handouts, speeches, exhibits, excerpts of things that he thought were most important. And then a surprising thing for you was he didn't recruit for these interviews only technical people. I remember vividly in a class that followed mine, we had a Harvard graduate. I'm pointing to Justin because he's a freshman at Harvard. But Rickover took in to his group a undergraduate who had been through Harvard, who was an English major. And this guy joined the technical group, matured with us, and after a year or so, he was very, very competent and fit well in. Not only did he fit well in, but he helped broaden the view of the rest of us in the group. And you probably know that the Admiral was a vivacious reader. And his library is in the Nimitz collection at the Academy. And what's interesting is his mock-ups of various textbooks. Okay, then still going on how the Admiral developed the education of his staff, we had designated commanding officers, and they were brought in, put in with all the groups, and it was at the discretion of the group leader, who was the supervisor of the prospective commanding officer selected. And we had instances where captains were put under ensigns because of who had the technical knowledge. And finally, the Admiral had diversity in his staff. And two examples I can think of were Alvin Radkowski, who is his physicist. He had the distinction of not having to work on Saturdays, which all the rest of us worked. And that was because he was an Orthodox Jew. He paid the price on Sunday when he occupied the office, and probably got a hell of a lot more done because he was not bothered. Then, actually, I worked for Richard Scott, who was a Mormon who was called on to do his duty to the Mormon church. He was pulled out for a year from being under the Admiral, sent to South America, and the Admiral then took him back, and Scott grew in the organization and turned out to be one of the senior people. Scott had one other characteristic which spoke miles of Rickover. The Admiral was not above taking a step that enhanced his program and his activity. Scott was related to the senator from Utah who was on the appropriations subcommittee that dealt with the Admiral's budget. I don't know whether that was ever brought up specifically, but the Admiral definitely kept Scott. But he kept Scott under a tight rein and demanded a lot of work from him. And hence, I felt that pressure as well. By the way, I was hiking in the West 10 years ago, and I ran into a group of Mormon students who were hiking. And I asked them about Scott, and it turns out he is one of the, I don't know what they call him now, but there's 10 people or so who are running the Mormon church. And Dick Scott was one of them at that time. So the admiral spent a lot of time, a lot of focus building and educating his people. And I saw a lot of people slides from the Commodore, had one here. People recognize the importance of a good staff, one that can think on their own, but can take direction at the same time. And just to close off this education thing, I've read a lot about the Admiral, and this was not developed when he was doing nuclear power. Before World War II, he served on capital ships, and he was in the Pacific on large cruisers, battleships. And what he used to do was handpick from the list of new recruits who were being sent out to man ships as people's enlistment. He used to go through and recruit the best people on paper that was available for his own division. And he didn't have much competition in doing that because the other guys were asleep and not focused on that kind of importance activity. Okay, so let me just move on. I wanted to mention pinks. One interesting way the Admiral knew what was going on through the whole organization and kept control was by having everything that was prepared and typed by his staff. There was a pink copy, and that pink copy was made as part of the collection that was given to the Admiral for his evening reading. And the next morning, they were redistributed through your supervisors to the individuals who wrote it with the markups of the Admiral. Okay. He also did, this is on the side of education, in his nuclear power activity, early on, he saw to it that technical material was written and distributed for the good of the country. So the first shielding manuals, the first book on uranium dioxide, standards, manuals, design manuals were created on nuclear power because at this time early on, he was doing the shipping port as well as the Nautilus. So he had access to all this information. And you should remember this from the pithy statement that he came up with, which was, water has no cracks. Now, what the hell does that mean? It meant that in designing A1W, the Enterprise, and putting shielding around the reactor, if you did it with just physical materials, they didn't all butt up and fit well together. You had cracks. A water tank was so much better if you could do it. So his statement in his shielding manual was, water has no cracks, and he lived by that. Okay, so let's just make sure you realize I'm going on now to his technical accomplishments. I won't go through them, but I'll mention them because they were essential. Zirconium was developed and used in the Naval Reactors Program first off. If we didn't have zirconium, we wouldn't have nuclear reactors. We needed a material that didn't absorb neutrons, that was strong enough at temperature and could be a structural material as well as somewhat of a shielding material. The Admiral developed reactors that lasted the life of the ship. Somebody mentioned that. That was inconceivable early on, and refueling took a lot of effort, money, and time. Now, you've got the core in the plant lasting the life of the plant. If you're a surface devotee, the naval reactors also developed a steam catapult based on the nuclear power plant. That was a difficult technical problem at the time. Okay, and let's close with what I think was his most important contribution. The one slide I'm going to show you. We got it up there? Okay, so you can see the top line says that the senior management of GPU, which was the company that owned 3 Mile Island, they got thrown out. And who came in but the Admiral's former technical leader in nuclear power, Phil Clark. He actually worked for Harry Mandel, and Harry Mandel was the senior reactor guy. Phil Clark left Naval Reactors, went to GPU. There was big controversy whether GPU could restart this remaining reactor at 3 Mile Island. Phil Clark went back to Rickover and said, do a review for me and publish it. Knowing Rickover, you can imagine that Clark was taking a risk because whatever Rickover found would be published. He found that Clark had redone the staff, but more than that, Rickover had this list of principles developed. I won't read them, but every one of them is a strong, strong point on how to run nuclear power plants. This was for civilian, but looking at the Commodore here today, I hope you see in here the relevance to operating any nuclear plant. The one, just a few comments, technical self-sufficiency, number 2. At the time of 3 Mile Island, there were a lot of utilities thinking it was cheaper to go hire somebody else to run their plants or review their technical sufficiency. The Admiral's point was your organization must be self-sufficient. Rising standards of excellence speaks of Jacob's ladder. If you're not climbing, improving your performance, you're slipping down. You've always got to improve and increase your standards. Radiation, facing facts, self-sufficient, importance of training and capacity to learn from experience. Those are things I think everybody knows the Admiral was on top of. But I'll close with the concept of total responsibility. If you're on the job and it's your job, you are responsible for everything that goes on in that system. You can't blame anybody, but even less than that, you can't rely on everybody. You're responsible for it. You've got to have trained them, led them, imbued them with this work ethic. This he gave to the civilian nuclear industry. Of course, we've had Fukushima and Chernobyl, but the U.S. system has held up. And I think it's a testament to the Admiral and what he gave us that we've performed well. And I think it's all given on this sheet. I'll stop there.
Okay, perfect. With that being said, that brings us to the Q&A portion of today's panel. So if you guys, the panelists, want to come right up to the stage, take a seat. If you guys do have questions, we have mics on either side of the stage up here. And you can line up at the mic, ask your question. If lining up in any way, shape, or form presents a challenge, just raise your hand and I can run a mic up to you guys. So yeah, I'm gonna run a mic right now actually, and then once that question's done, we can go ahead and move on with the questions at the mics on the side.
So I had a somewhat maybe frivolous question, but I was wondering if any of you had any opinions on the submersible that exploded at the Titanic and what went wrong with it. And if there are, I assume that that wasn't a one-off thing, that there are people out there who are doing DIY activities like that, and if that kind of comes in contact with your work as well and what you do.
Yes, that's a great question. I was embedded in the operational team here in Boston when that happened as a technical expert from Woods Hole. There were a handful of people that were there as it played out. And one of my primary responsibilities was to explain to the officials who were in charge, that did an amazing job, by the way, what the engineering was behind that system, and maybe deduce what we could learn quickly enough to do our jobs as it played out. So one of the big things about that system was that it was a carbon fiber system, and it was of a cylindrical design, and the end caps were made of titanium. So all the people in this room that are technical in nature know that you don't use, number one, you don't go deep with a cylinder, you go deep with a sphere. And then you don't use dissimilar metals that collapse with different, Young's modulus. So all those rules were violated, and carbon fiber is not the best material to go deep in the ocean with. If you look at the submersible at Woods Hole, Alvin, it's a sphere made of titanium. So that submarine was optimized for numbers of people that were paying, and that's why it was a cylinder. So that's not if you're going to go that deep in the ocean, it's got to either be for something noble like national defense or science.
And so, you know, if you're in the Navy long enough and are senior enough, you get to tell some sea stories. So this is not on the Titan, but on deployment, I was out on Guam, so I was in the Western Pacific for months at a time with my crew, having a great time doing what the nation needed us to do. And I got home, and there's a tourist submarine in Guam, in Apra Harbor, and called the Atlantis. And they take you out, you know, a lot of Japanese tourists, a lot of other folks. And they submerge you in Apra Harbor to see the coral and the fish and the sharks and everything. And my wife decided to take our children, our 3 children, and her parents, who were visiting Guam while I was on deployment, and they went out to this tourist submarine. And when she told me that, when I got back, I said, "You did what? You got on that thing? Why would you do that?" Because, you know, having lived the world that we live with the principles that Admiral Rickover has instilled in the Naval Nuclear Propulsion program and the design that General Dynamics and Electric Boat and others put into their submarines, I know what it takes to engineer that. And you know, the Atlantis, although you know, probably kept some tourists you know, excited with all Finding Nemo there in the bottom of Apra Harbor, I know that it wasn't designed and engineered the way our submarines are, and I wouldn't want my wife or kids to ever get on one of those again. So that's my sea story. So
we took it as a cautionary tale. We're trying to push the envelope, trying and figure out new things, trusting our tools more. And often you forget of the huge body of work that's been done, the hard lessons learned, the lives lost with those lessons learned. And when all of a sudden you have a financial incentive to fit as many people, and you're like, you know what, I'll trust this tool because it says it'll be fine, and I'll make sure I monitor it kind. But that is pushing the envelope for what purpose, and what is the result of pushing the envelope too much. So that's something that we took, you know, my team and I, we sat down and thought about, like, we have to rely on tools a lot, and analytical tools, not as opposed to physical testing because of the nature of the cost and the time. How do we leverage that? Are we over leveraging it? So it's just you have people's lives at stake. So you have to make sure you have the right intentions and the right clear-headedness to actually go forward with that.
Yeah, can you hear this? Yeah, my question, we've been talking about nuclear-powered submarines, and obviously nuclear power totally revolutionized what the submarine is and what it can do. I keep reading about smaller countries, even some larger countries, that have developed new non-nuclear submarines. There's a lot of new technology that applies to them. You know, battery technology's improved, a lot of improvements. And they're making the argument that in some instances, a smaller non-nuclear submarine can be more effective than a nuclear submarine. So is the Navy thinking about submarines other than nuclear power?
So the Navy, this is, I would say, a frequent topic that comes up back and forth since I've been in the Navy for the last 24 years. It's come up a couple times. So again, I have a sea story to tell you a little bit of this. So on one of my deployments in command on Oklahoma City, we were, you know, silent for, you know, 45, 50 days, and we came up finally to get a port call and download a bunch of message traffic, and I got a message that said, "You're going to take some Royal Australian Navy guys on your next mission." And I was frustrated because I thought, oh man, they're going to make me do some exercises and some really important tasking, and I wanted to do the most important stuff for the country. And then I realized that they were all read into the same security clearance and classification and all that stuff that we had, so we got to do the really cool stuff. So one of the riders was a prospective commanding officer of one of the Collins-class submarines that the Royal Australian Navy has. It's a 6-class ship, diesel-electric, submarine class, and this gentleman was going to go take command of HMAS Rankin, which was one of those 6 submarines. By the end of his ride for that mission, which was about 45 days, his jaw was on the floor saying, "Our submarine force can't do what your submarine force does. That nuclear-capable submarine that you have, U.S. Navy, is hands down way better than the diesel boats that they have." And I'd like to say that maybe that was a little bit of the impetus behind the AUKUS program, the Australian, UK, US agreement. I don't know that for a fact, but I like to think it. because I know that that person went on to be a Commodore in his submarine force and is now integrated into the AUKUS program at the Navy Yard down in Washington, D.C. He's a key player for his nation. And I'd like to say that we proved to a diesel submarine boat nation the advantages of nuclear power, and it's worth to do it because of the speed, the endurance, what that extra power can provide with additional systems, sonar capability, weapon systems capability, things that you can't get out of a battery, even if it's a more technical, more capable battery. You can't reproduce what the Naval Nuclear Propulsion Program has produced for our Navy. So that's one person's take, having seen it both, in the Western Pacific and on staffs, throughout my naval career.
Okay, yes.
I can answer some of that question too. When I was in command also of a Los Angeles class fast attack submarine, I can recall getting a message that said best possible speed, and there was an X on the map, and I drove that submarine 1,850 miles as fast as it would go, and you tell me a diesel electric submarine that can do that.
Can you give us any update on the mapping of the ocean? Because I understand stealth is one of the benefits, right, of the submarines, but yet we also hear about this initiative to start mapping the ocean. So I appreciate it.
Yeah, I can speak a little bit of that. My colleagues at Woods Hole are deeply involved with this, but I will speak on their behalf. The ocean is wildly undersampled, as you point out, right? And knowing the bottom of the ocean, it's nowhere near 30%. It is wildly unknown territory. I mean, some of the data that we use is what's called, even the best data is what we call DB5 data, which means that point in the ocean is an average of guesses in 5 square nautical miles, right? But as systems get better, as we can go deeper, as they're cheaper, then we map more of the ocean floor. We also instrument more of the ocean, and it's not just the Navy that does that. A lot of academic organizations put nodes out in the ocean to catch a whole lot of data. Woods Hole has 10 outposts that they move all around the world that continuously collect data wherever we put them. And okay, it's a point, but it's 365 days out of the year. That point, it's known what the temperature is, what the salinity is, what the sound velocity profile is. And the more this technology comes down in price, the more sampled the ocean will be. But it is true that we know more about our solar system in some ways than we do our own ocean.
And our enemies, to the extent to which they're engaging in this mapping.
So, the submarine force has had 2 Class A mishap with submarines. USS San Francisco hit a uncharted seamount in the Western Pacific, and the USS Connecticut more recently went into some very poorly charted areas and got the top of an undersea mountain. And that is in the Ring of Fire, and I'm sure people have heard that term. There are undersea volcanoes that are erupting daily in the Western Pacific on the Ring of Fire, and those sea mountains are changing with those eruptions. For our reviews of charts, right? So as a captain of a submarine, I reviewed every chart that we navigated on to make sure we understood the water we were navigating. And this is no kidding. One chart that I looked at, you can see time periodicities of where the sounding data came from. There was one listed from Magellan. So just take that with a grain of salt, and I'm not even joking. A chart had a sounding from Magellan. Magellan did go through Guam on his tour around the globe hundreds of years ago. So that, unfortunately, some of the places in the ocean are not much better than that.
Yeah, I just wanted to say thank you for the presentations. This is content I'm not usually exposed to, so I'm actually fascinated by it. And one thing that's on my mind is diversity in STEM fields, which I'm sure you recognize as a problem, and I can only imagine it may be a bit more severe in your domain. And given the importance and the impact of the work that you all do, I'm curious what strategies you have to increase representation of women and other underrepresented groups, and are those strategies actually having an impact and being successful?
Great. So the submarine force integrated women into our ranks just over a decade ago. We called it the Women in Submarines program. We are now going away from the term because we consider pretty much fully integrated. About 20 to 25% of our nuclear officer sessions every year are women, and there's no limit to that number. The more women that want to join the subforce, the better. I have 2 submarines in my squadron that are not what the Navy would call the women in submarines, but there's criteria that we can meet in order to just take women riders. And so because we have so many new construction submarines that are manned with women, they need to get experience at sea. So USS Delaware and USS Indiana are 2 of my submarines that have had women who are not permanently stationed on their submarines, but have been riding their submarines for over a year. Both submarines have deployed with women to give them experience. And we're just about to the point where we're going to allow women on every submarine. And we're even considering integrated berthing, which means that a stateroom could have women and men in it, or a bunk room, which right now we do keep the women in a separate berthing location just right next to as you would imagine, life on a submarine's tight, so there isn't a lot of me space. It's really just your rack, but we've found a way to make it work, and I'll tell you, the women that I've seen at sea are impressive. I wish I had some of them on my submarine, so.
At Electric Boat, as we've had the peace dividend from the Cold War and a lot of our demographics shifted older, we've had no choice but to make sure we cast as wide a net as possible. So we have a lot of our own initiatives, a lot of groups for supporting, a lot of outreach, and it is paying dividends. You go down, especially where I work in the engineering offices, and the people around are more diverse and younger, and I think we're better for it.
Yes, I can tell you the Woods Hole Oceanographic, it is a major thrust, and I would say it always has been, but even more so now. So I would say 30% of my lab is female. Our number 2 person in the lab, our program manager just under me, was a very accomplished female program manager who was a pioneer in engineering. And our newest hire is also female, and she is a absolute rock star computer programmer. So if you look at Woods Hole, we deploy on ships everywhere. My lead operator on submarines is a female, and she goes on crews that are not integrated. And we go on ships all over the world. And we have commingled bunking. It's just not an issue. They're out there doing the job every day.
So I remember that the Admiral had a design for nuclear propulsion for spacecraft. I wonder if you could speak to that and why it was abandoned, or if it's still being used in some way.
Naval Reactors was asked some years ago by NASA to get involved in the space program. That was far later than the Admiral was on running it. They geared up, they hired a lot of people in Bettis and Keppel, and then the rug was pulled out from under them by NASA, and nothing happened further, and Naval Reactors hasn't been involved that I know of in space activity.
NASA has looked at nuclear propulsion on and off. I'm not sure exactly what they're doing now, but there are papers out there that talk about how you would do that. That's all I'm going to say.
Yeah, and this is outside my expertise, but I would just say, I call myself an operational engineer, right? I took an engineering degree. I didn't really do much with it other than kind of the foundational math and science aspects of it. I don't do ocean engineering necessarily in my field of expertise. But as someone with a technical background, I would say the complexity of putting something through that flight up to space and the friction that it would have and the jostling that it would have. Jostling a nuclear reactor is probably not a good plan. So this probably adds a lot of engineering complexity that would probably in today's day be cost prohibitive, I would imagine.
So you talked quite a bit about the materials that you use in the tech designs for the different types of subs, but especially when there were these issues with the tourist sub, one of the things that crossed my mind is that there are big differences not just in how they built this specific one, but also in the standards for testing, the redundancy, the risk management. If I'm going down in one of those subs and it's controlled by a video game controller, I'd like to have at least 2 of those on board, right? And then also when they couldn't find the sub, in your business, there might be cases where you don't want it to be found, but if you've got sailors in there on the surface, I imagine you do. I was hoping you could comment more on those general principles of how you keep your people safe in those situations with the design.
Well, I'll say one thing. I commented on it earlier, but I'll go a little farther, which is you reach a certain depth limit where the cost becomes prohibitive to be safe if you're in the tourist business, okay? So a tourist submarine in Guam, I share the Commodore's concerns, but that's pretty shallow. But when you're going to the Titanic, that's 10,000 feet. So 10,000 feet, you're well below that line where tourism can pay for the safety needed, right? So our Alvin submersible, not everybody knows that, but it's actually certified by the Navy. So we use the Navy certification rules to certify that system for safety. The Titan submersible that was operated in international waters had no certification standard, right? It didn't have American Bureau of Ships, it didn't have a US Navy certification, and then there's a couple others, right? But the point of those certifications is to make sure you have done your homework, and doing that homework is prohibitively expensive. Now, science can afford it and national defense can afford it, but you can't sidestep that cost, right? So, and you're right, it's an incredible amount of checks, rechecks, material checks, tests. When we recertified the Sphere in Alvin, it took a year's worth of paperwork, so.
So after the loss of the USS Thresher, when she left the Portsmouth Naval Shipyard, back in the 60s on sea trials, the Submarine Force instituted the SubSafe program. So there are a mountain of criteria to make sure that a submarine is certified to the depths that we're allowed to operate. One way we track them is there's a unrestricted operations, or URO. There's a whole bunch of different UROs. They test the hull, the pieces, parts of the submarine that are connected to the hull, the systems that would get the ship back to the surface, and there's periodic testing, and if you can't complete the testing in the time period, they say, okay, surface, and you can't submerge again until we've verified that all your systems operate per design. And we, in our 5-year and longer periodicity maintenance items, the ship is in a dry dock, they scrape paint, they test the hull portions of it, they look for cracks, defects, and they fix those before you're allowed to submerge again. We take it pretty seriously. Ask some of the crew of a submarine like the USS Boise. Her hull certification expired, and her maintenance period got delayed because of backups at the shipyard. She sat idle next to the pier, so one of our fast attack submarines, for 3 years, because there was no way that they were going to let her submerge because she hadn't done that periodic maintenance and check. So the standards and principles that Admiral Rickover set into our program, into the subforce, again, will ensure that we don't have another Thresher program or issue.
when you look at our submarine designs, there's backups upon backups. There's multiple ways to do things. They're tested. They're worked through with crews, with the engineers, everyone, and those we did not learn those the easy way, as the Commodore just said. So yes, the Titan it's a cautionary tale, but the submarine force has already had its cautionary tale. And the goal is to make sure that doesn't happen again. That's the point of rising excellence, right? Complacency is basically just going backwards because everything else is still moving forwards around you. And so one of the things we learned is testing and being able to get enough data to have confidence. And the Titan just did not do that for both economic reasons and, depending on how you look at it, hubris.
Perfect. I think we have time for this one last question, and then we'll wrap things up.
So I think there are hard technical problems in the world, but some of the worst problems are actually people problems. And I think that's one of the things the Admiral is really good at, is setting up an organization where the people problems get dealt with, and where people are made their best selves so they can perform. But the Admiral's been gone for a long time, so I'm wondering if you can tell us a little bit about how you've maintained that culture and how you've had to adapt it.
It's a great question. So, if there are a couple statements that I would say Naval Reactors lives by, is that we try to breed a culture of excellence. So that is one thing that we say. We also say that we're a learning organization. And so, how I translate that to my commanding officers and the crews that I sail with periodically, although I only go underway for 4 or 5 days at a time now, which is nice. But when I sail with them, some of the things I ensure that I foot stomp is that not only do we as a submarine force need to always continuously be self-assessing, because that's important, right? To look at, hey, how did that go? Could we do it better? But that's only half of how we keep the culture of excellence that we have. The other half is self-improving, right? So you could have a great culture of self-assessment, identify all these things that you want to do better, but if you don't take that next step for self-improvement, then you won't get better, right? And so that culture of excellence, that we talk about, that Admiral Rickover instilled, the directors of naval reactors that have followed since then, and there's only been 7 others, soon to be 8, once Admiral Houston takes over for Admiral Caldwell. That self-assessment and self-improvement attitude is pinnacle for how we do business on a day-to-day, day-to-day on the deck plate. And if you lose that, then the continuous learning and culture of excellence will start to fade. And I think that's how we've been able to maintain that. Some people don't know. Every commanding officer of a U.S. Navy submarine will send the director of naval reactors a letter quarterly if you're operating, monthly if you're in a shipyard, talking to him directly. So that's 05, commander in the United States Navy, to 010, 4-star admiral, direct correspondence. That's unheard of in a chain of command in the military. But you send that letter to tell him how things are going, areas that you're working on, areas you may need help. Make sure you've told your Commodore if you're telling the Admiral that you need help in an area. It's lessons to learn by. I think that's a number of things that we do within the submarine force that maintain the standards, principles, and culture that Admiral Rickover instilled in 1950s through 1980s when he retired.
Okay, perfect. With that being said, that concludes today's panels. Let's give one more big thank you to our panelists today.